Entity framework, our tool.
Countdown commencing. T-minus 2 minutes.
Jeremy Likness. Shiro Dance.
Grace Lanson.
Martha Vickers.
.NET data. T-minus 1 minute. Thirty seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. We are go for .NET Data Community Stand-Up.
Hello, welcome to .NET Data Community Stand-Up. We've got a great show for you today, but before we get started, I just want to acknowledge and express our support for the Ukraine and everything that's going on right now. We have a Ukrainian team member on our team, plus someone from Poland. And of course, everybody in the world is looking on and seeing what's happening there. So we debated whether we should continue as normal with this live stream, and we want to do it. You know, Andrew in particular said, you know, a lot of people get help out of having distractions for things like this. So we just want to acknowledge that before we start and let everyone know that we're thinking of people there. So with that, today we have the big showdown. Well, not really, but we have GraphQL. Michael Staib is author of HotChocolate, creator of HotChocolate, GraphQL library, and Hassan Habib, is that right? Something like that, who is Microsoft person and OData extraordinaire, does lots of things on OData. Now, we always get, whenever we do a GraphQL thing, we always get asked, what about OData? And whenever we do an OData thing, we get asked, well, what about GraphQL? And typically the answer is, well, they're good at different things, but there is overlap, and in people's mind, there's definitely overlap. So we figured, let's get both people on. Let's get questions from everybody out there, and let's see what each can do well, and where you can make the best use of both of these technologies. So we'll get down to that in just a second. We also have Shai and Jeremy here as usual. And we'll start off with just a quick what's going on in the world of the unicorn with the state of the unicorn. So firstly, we've got two releases out, at least since I was last on the show. We've got EF7 or EF Core 7.0, which we're calling EF7 Preview 1. It doesn't have anything big in it yet. Big things that we're working on right now include TPC mapping, JSON columns, a bunch of perf stuff, T4 templates. There's lots of stuff, big features going on, but they're not in the previews as yet. If you do want to ever find out what's in a release, then the releases page here, which is in the EF Core repo, typically I update it like the day of or the day after the release with a list of the issues that are fixed. So you can see in the patch release here, we've got 9 important bug fixes. That's in addition to, all of the bug fixes we had in 6.02 and 6.01. And then in preview 1, nothing big, but a lot of kind of small things that, for most people probably don't make much difference. But if you're waiting for this particular feature in your code, then it's really good to have these. So just things like being able to specify ascending or descending index ordering, not getting a parameterless constructor when you're not using on configuring in scaffolding. This was a community contribution, so thanks to that. And a bunch more kind of little things in there. So check that out in preview 1. Plus, of course, preview 1 also has bug fixes that we don't consider high priority enough, or they may be too risky to put in the patch releases. So, and you don't need to have .NET 7 to use the daily builds or the previews of EF7. We still target .NET 6, so you don't need to go to the latest and greatest of everything to get these bits. Okay, so in addition to that, we've got a bunch of new doc stuff. So Jeremy's been working on multi-tenancy docs. So let's go up here, multi-tenancy. So there's a lot of getting lost with my mouse again. There's a lot of details about different ways to do multi-tenancy, Blazor solution. Lots of good stuff here. So take a look at that if you're doing multi-tenancy. In addition, Jeremy's updated a really good Cosmos DB sample that he'd worked on outside of the normal docs, but we've now got this on GitHub in the EF Docs repo, so you can play with that for Cosmos DB. And then if you are ever wondering what's in support for all of the different evolutions of Entity Framework that have happened over the years, released in different ways and different things, we've now got that basically published officially. You can find out whether, which versions are supported, even if you go back to some of these older ones. Sneak peek, most of the older ones aren't supported, but at least it says that now. So, so that's, I think, all we had in the State of the Unicorn, multi-tenancy, Cosmos DB planetary doc sample, and support policies. So now we've done that, we can go over and start talking about GraphQL and OData. So maybe, and send your questions, by the way. We definitely want to make this people asking questions about stuff. But maybe we could start off with just asking both of you to give an overview of how you see the two different technologies. So should we go with oldest first? Hassan,
I do look like Gandalf, and I work with an ancient technology. But I'll go first, if that's okay. Hi everyone. Just for the people watching this for the first time, my name is Hassan Habib. I am the senior software engineer at Microsoft. These days, I'm hanging out with the folks that build networking inside Microsoft, and we're evolving our own platforms and building it, from scratch. I've been, very obsessed with OData for several years now. It started with advocacy, working around just showing people what it can do. And, and I started to kind of, lean a little bit more, getting closer and closer into the identity team, Samshu, developing the main library. And then recently we started thinking about branching off of the existing OData and building OData Neo that is, protocol agnostic, has transcendence capability, more microservices friendly. We're taking it to the next level. And I'm very excited to be here today to talk about OData.
Sounds good. Michael?
Yeah, I'm Mike Stipe. I'm a member of the GraphQL steering committee, so the people that essentially, vote on the spec and get the spec to move forward. And I'm also the author of HotChocolate, which is a GraphQL library for .NET to build servers, clients, and stuff like that. And yeah, I'm since 2016 really only involved in GraphQL. And before that, I actually was very invested in OData. And I was one of the persons that when I was pushed towards OData, said, why should we push towards GraphQL? I was in the position to say very naively, why should we use GraphQL? It's just looks like Facebook's flavor of OData. So if you're in that corner, I think it's not wrong to make this wrong assumption in the beginning, because there is an overlap. But as soon as we go in deeper, and I hope the discussion will go there, you will see that it has actually different mindsets behind these technologies.
So, where would you say that GraphQL excels? Like, what are the primary scenarios where you would recommend somebody use GraphQL? I'm not really talking about as opposed to OData. I'm saying, okay, what problems would you encounter in the world and say GraphQL is a good solution for that?
Yeah, I would more look from a different angle at that. Okay. So I said mindsets, right? And that is first one of the major differences. Like if you look at OData, it essentially came from databases. I don't know if somebody still remembers the RIA services that we had in WCF.
Oh, yeah.
And if you look at OData from the beginning, it was, we had this atom pub sub format, this XML stuff. It wasn't even using JSON back then. So it came from a very, very different background where you wanted to make data accessible in the cloud. So you had this, I would say, database view on these things. Whereas if you look on the GraphQL stuff, you have a completely different mindset where Facebook faced a problem with their mobile applications, and they wanted to make their APIs accessible in a more efficient way. So they have a really different view on this thing. There's a different problem they wanted to solve. And in their specific case, it was a Facebook application that wanted to access data from their Facebook REST APIs. So they had a couple of issues that they wanted to solve: overfetching, underfetching, and also make their API accessible without losing the context. Like if you go in the REST world, you always have to deal with DTOs, you copy data, you make it just transportable to somewhere. Whereas in GraphQL, you have all the type system things that you have in your APIs. Like when you build in C#, you have interfaces, you have unions. Or unions we don't have yet, but I hope they come soon with the next version of C#. But anyway, you have all those type system constructs. And now you are able to expose your APIs in a much richer way without losing too much context. So that are the backgrounds where these technologies come from. And there you already can see they have different angles or different use cases with that.
So it's almost like OData is a perspective from the database pushing stuff up, and then so that things outside can consume it. And GraphQL is from a perspective, I've got a UI and I want to reach down and grab stuff out of my REST APIs. I was, when I joined the Entity Framework team, it was a time when what became WCF Data Services had basically just split off from the Entity Framework team. So we were all still basically in the same offices, and it's called Project Astoria at the time for those who remember it. And that was definitely based around the concept of we have this entity data model, and we build Entity Framework around that. Hey, why don't we expose REST APIs over this entity data model? And then that evolved into the OData spec, which originally, EDM was used by both EF and OData, and that's where we came from. So yeah, that's definitely how that evolved.
Yeah, and you see that still, like in OData, you have all those filter APIs and stuff. Where in GraphQL you don't have that baked in. It's more about the application layer. And the slogan for GraphQL is also it's a query language for your API. So it's not really a query language. It's more like you can select different APIs with it, and then so it's a different.
You could still do, someone might argue, like you could still do something similar with OData batching. Like if you go and say, I want to basically hit particular endpoints, right, to be able to select a bunch of data, right, and get an independent result, for each and every one of these, data results. That's how you can kind of control that through OData. You're still going to have to kind of, in a GraphQL way, or how GraphQL works, you're pushing in you're posting a request and you're getting back data that matches this contract that the client dictates. You could do something very similar, with OData, with batching, when you go and say, okay, I want these bunch of requests. They can be get, they can be post. You can actually bundle up a bunch of, not necessarily just querying, but also, persisting and writing within the API as well. I'm still kind of educating myself about GraphQL, so I guess if that's okay, Arthur, can I ask a question? Go ahead.
Absolutely, yeah.
So Michael, just from my perspective, because I'm very excited about new technologies. In fact, actually, the way, you started with OData, you went into GraphQL. I was going searching for something new to learn, so I ended up with GraphQL, and I thought, I wonder if Microsoft has something. And then I ended up in OData. My very first video about OData is actually, do you like GraphQL? Try OData. That was like my very first. But the question to Michael is, can you actually bundle operations? Not just querying, but I want to do multiple operations. I want to update, I want to write, I want to basically query within one big blob that you're sending through GraphQL through the API in .NET.
Yes, that can be done. That's a basic concept in GraphQL, and so you essentially can chain these. That's one of the baked-in things in the specification, that you essentially have these flows, and it's and it says so when you look in the spec specifically for mutations. Mutations are executed as sequential. So if you send a request with two mutations, the first one is executed first, then a second, and that allows you to write these mutation flows essentially. But there are other concepts also. There's then also mutation batching, where you have multiple requests that contain maybe multiple mutations that are changed, and then can export data into the following request. So that's more complex, but that's baked into GraphQL. Yes, you can do that.
So Hassan, so we talked a bit about where OData has come from, but that was a long time ago. So where do you see it now? Where do you see it excelling now and evolving also into the future?
Yeah, absolutely. So just earlier this year, I've had, kind of finalized the discussions with, the identity team, OData team, worked with the community, really appreciate the work that, the community have come together and started to kind of evolve and take OData to the next level. I put three main aspects of, revolutionizing OData, taking it to the next level and making it microservice friendly, making it something that is plug and play, irregardless of the technology or the framework. So we started with technology, being a technology agnostic, framework. So what I want to do is that I don't want to be tied to ASP.NET. I don't even want to be tied to RESTful APIs at all. I want people to be able to go and say, I have this backend service, which is just reading parameters from whatever it wants to read the parameters from, and be able to execute and run that. So this way I'm detaching the technology itself from being specific to REST or APIs, But more importantly, I wanted to take OData also to the next level in terms of microservices. When I design services, at Microsoft and outside of Microsoft, it's very likely that you'll run into a situation where you want to split your query across multiple microservices and let every service kind of collect that data for you. But more importantly, you also want to aggregate and transcend that query to the next layer without having to worry about, oh, I need to do something hacky to make this happen, right? I want this transcendence to be smooth and I want it to be simple. So the transcendence aspect actually brought us down as a community to the idea of the tokenization part, and setting an agnostic model that can be converted into whatever you want it to be converted to. You can take an OData query and turn it back into a query as a string back to the API. You can basically convert it into an expression, so you can hit the database through the entity framework. You can turn it into whatever you want. And the last thing that before I last time when I tried to say the last thing, I dropped off the call. I shut down the browser. So I'm gonna try to keep my
The
hands
most
away.
important thing right now, and then he's gone.
So the most important thing about this is that I want OData to be a marketplace. What that basically means is that, okay, we have this standard, the OData standard that's adhered and agreed upon by one of the biggest tech companies in the world. You can't actually go into a tech company, including Facebook, and you're very likely to find an OData enabled API somewhere. That's how widespread it is. World Health Organizations, all of that is using OData. But I wanted to do something more. I want to say I don't want to be tied up to a particular parameters. Like when we in OData we do $select, $order by, right? I want people to be able to go and say, no, I want to make $fuzzy search. I want to make compute, whatever that clause may be. And in that way you can basically publish a NuGet package on NuGet and basically download and install it, and now all of a sudden your OData enabled whatever API or whatever exposure layer now can support this additional capability. Working with clients and customers and working with people that are using OData on a daily basis, it just popped up this idea of rewritable software that you're writing out there, and you want people to be able to pick it up as a component and throw it away and write their own and plug it back in with the least amount of effort possible. And I think using OData as like a playground, kind of greenfield kind of thing to try something like that out was perfect for me and the community to kind of try out. And we're meeting 3 times a week, we're pushing it through, and we're having a little bit of fun. Yeah.
So we had a question pop up in chat. I want to make sure these get front and center. I think I have in my head what the answer would be, but Michael, how about GraphQL for microservices, like communicate backend services?
So, I mean, GraphQL is built with that in mind, right? Often people use GraphQL over microservices. So essentially, GraphQL is this, I would say, it's actually a fix to the microservice world. Often people use a GraphQL layer as a one source of truth where you can access all your data. And behind this actually sits multiple microservices, and GraphQL aggregates them. That's basically how most GraphQL setups are. Often you even have OData or GraphQL behind that and put GraphQL just in front of that to have a modern API layer to access your data. And
so there's sorry, go ahead.
Yeah, no, go.
So there's actually a lot of similarity between what GraphQL does there and what Hassan was just talking about in terms of the transcendency and the bringing multiple sources together, not just REST APIs, right? In GraphQL, you can also do that kind of thing where you've got different services, microservices potentially behind a GraphQL, which other microservices are sitting on, which maybe your UI, if you have one, is sitting on that too, or on a different one. It's very much a bring it all together from different places, right?
I would say so OData is very focused on these filters and stuff like that to query things, where GraphQL is not. It doesn't even have to have a filter to work. So it's more about data trees, and it's it's essentially exposing your models or your APIs with trees. And this, it also goes hand in hand with concepts like CQRS, because in GraphQL you have these distinctions between read-only models. Queries essentially are read-only. Then you have mutations which are very specific, changing data, and then you have the real-time part, which is subscriptions. And this goes hand in hand, so it's much more decisive and geared towards APIs, where even when Hassan explained the concepts around OData Neo, it's all about around these filters, so filtering data, and this is so there's one of the main differences, I would say. And
if I can just share the screen and visualize, because I really want to understand this too. This is a problem that I'm trying to solve, and I'm really interested to see what Michael says about this. So Michael, this is how I design my microservices anyway. Imagine that you have a system like this. This is your, microservice architecture. You want to hide away your internal services. So you have this nice gatekeeper. This is a gatekeeper pattern here that basically exposes your architecture to the outside world, UIs, APIs, other system, whatever the case may be. So the problem that we're solving with OData Neo is that assume that you have an API in here, and this API basically you're receiving an OData query. Assume the question, I'm going to say query to cover both OData and GraphQL, just to see if we can make this work. Is it possible today that I can go and say, and this is just for my learning, I really want to know what this looks like. Now you have your query coming in, and your service is able to kind of transcend that all the way down to other microservices who are also, say, GraphQL enabled, right? So let's say this guy has all the students, right? And this guy has all the teachers, and this guy has all the courses, right? And all of these guys.
I talked to Daryl from the Microsoft Graph team, and we explored this problem. And GraphQL is today, this is plug and play in GraphQL. You even deal with overlapping data. Let's say you have in courses also some data for teachers. So with concepts like Apollo Federation, which is GraphQL Federation standard, but there are others. HotChocolate has a federation standard there. The execution engine will also ensure that we use the least possible downstream services. So we will optimize, we will know there is overlapping data even in the course microservice. So we don't have to go to teacher to get maybe the teacher ID, because we know it's also in the courses. When we fetch the courses, we might even have the teacher name there as an overlap. So GraphQL actually handles also these kinds of things. Yes. So that is plug and play.
So if you'd allow me, how does that work? Like, let's say you have a controller and a service and a broker, and this broker is the guy that talks to all the other APIs behind the scene, right? So you're getting, so this is your in-tier architecture, and you have a service in here, and you have a little API controller sitting in here, right? And this is your GraphQL query coming into your API. Okay. Your broker here, let's say your service is talking to a bunch of brokers, and every service has its own. Think of brokers as clients for your APIs, right? So, people call them all kinds of different things, right? Adapters, clients, repositories, whatever people want to call it, right? And do you have to add extra work on your integration layer to be able to go and talk to the school and teacher APIs? Like I'm a .NET guy, I'm working with this, and my controller is exposing an IEnumerable, like it exposes a list of school data that includes courses and students and teachers, right? And you have your GraphQL query coming from here, right through here. Do you have to do more work on this layer in addition to this guy? Or does it just...
So if you would do that in a GraphQL word, you would essentially have split your graphs into microservice GraphQLs or downstream GraphQL subgraphs, you would say.
Okay.
And these subgraphs can be auto-merged. Yes, you don't have to do anything.
Yeah.
And there are even adapters like the Guild. It's an open source community of GraphQL engineers that build plugin adapters for like OData, databases, what have you. So anything like Thrift, gRPC, you can just plug it in, and it essentially appears to the GraphQL gateway as a GraphQL subgraph, and is auto-merged. Yes.
Who's doing the subgraphing? Is it the service or some additional work? Like how do you break? Just forgive me, I'm really trying to learn this. So who does break that one big graph query into smaller graph queries?
That is the gateway essentially. So there are certain terms. So this is for people to understand. It's a bit to put your head around. But essentially, you're composing your supergraph from your subgraphs, and the supergraph has information, and that is not exposed to the public world. But the supergraph has information about things like where's overlap, which field in my graph can I get where.
Okay.
And each field might be accessible from multiple downstream services from your subgraphs.
Yeah.
Like maybe a person's name can be gotten from all the subgraphs.
That's right.
And then the GraphQL server, the gateway GraphQL server, will essentially create, when it gets a query initially, will create a query plan, and this query plan then knows where to most efficiently get the data, and you can even rewrite the query plan. So if you think it's not correctly tuned, you can tune it. Okay, don't get it there, get it here. And then this is distributed, and it's all executed mostly in parallel. So with the least amount of fetches from the downstream services. This is essentially what Netflix, for instance, is doing. And Netflix is running on GraphQL. They have a massive scale, so this is really tested on a massive scale. So any big internet company is running essentially GraphQL in such a way.
We need a hands up feature like they have on Teams.
Yeah, we do.
Go ahead. Yeah, go ahead.
I definitely have. So, question about the overlap. So, is it assumed, Michael, then that where there's overlap, that it is consistent between those things, so it doesn't matter where you get it from, or at least as consistent as one needs it to be for the application? Maybe it's eventually consistent, and Netflix says actually something is slightly out of date, like maybe it's only 4.5 now. They don't use stars now, they used to. That's old school.
But these are standard microservice problems, or your microservices own your data, and there might be duplicated data in your microservices.
But it doesn't do OData itself doesn't do anything to try and say
GraphQL doesn't.
Sorry, GraphQL.
No. It essentially you say you essentially, by exposing your subgraphs, you essentially say I'm having here an entity user. Maybe I'm owning this entity, and then there might be others, other services that actually expose the same information because they also have that.
Yeah, absolutely.
Like maybe if you have the standard example is there, you have a products catalog, and you have reviews and you have users. So the reviews maybe have cached, the review service may have cached the username that wrote the review just to have a faster display.
It's the antithesis of normalization.
Yeah. So if you're querying now for the review of the product service, you don't have to get the user from the user service because you already have it on the review service. And if there are substructures where you have the same user deeper in the graph, then you don't have to still go to the service because you have already cached that in your execution pipeline. So GraphQL will essentially solve that with Federation. Sorry.
Shai and Jeremy.
Let's
I'll let Shai
go to
go.
Jeremy.
I've been waiting longer, but Shai's probably more.
No, go ahead, Jeremy.
Yeah, go ahead.
No, I was going to say, so we're backing up a little bit, but I've always thought, and Hassan, you can correct me if I'm wrong on the OData side, same thing, Michael, is I look at GraphQL as a way of a front end requesting a rich object graph, and then there's a set of ways that is realized or materialized. And OData is more used today, I believe, as a way of serializing queries over REST.
That's
Exactly.
right.
And there's a fundamental difference between those. But the two interesting cases I've seen of dealing with disparate data sources. So one of the most common reasons people tell me they use GraphQL is when they're modernizing their stack. And so they start building everything new on GraphQL, but they're actually a facade, right? They're actually handing off
Interfacing
the
with OData.
WCF
Yeah,
or
like a
OData
shim.
or something else in the back. But the
Yeah.
other interesting thing is when there's an existing set of services and they're stitched together, right? So I use the example that I think resonates for people is that there's a weather service that gives me, the weather and locations. There's a restaurant service that gives me ratings. So if I say I want to eat outdoors, give me the list of restaurants in where the weather's going to be good, right? And you can basically put a front end request that looks like you're just asking an endpoint for that information, even though it's fanning out to the services behind it. I just wanted to throw that in.
Yeah.
Shai?
Yeah, and to just a thing, because we are we were talking about composing graphs, right? And that is also because you threw that in, Jeremy. It's
Okay.
why it's baked into GraphQL, composing from multiple subgraphs or subdata. Because often you start with GraphQL as a very thin layer over your existing infrastructure. Like you maybe have microservices, you maybe have OData, you maybe have gRPC services, and then you put GraphQL over it. And you write your resolvers on top of that, and then you fetch from all these subdata sources. So that's a typical way you introduce GraphQL.
Shai?
Yeah, so I wanted to build a question on Jeremy's very insightful comment from just before. So we talked about at some point about how the roots of these two technologies, GraphQL, maybe came a bit more from the front end in Facebook, querying stuff, bringing stuff from the back end, whereas possibly OData was more a way to expose a database or at least a query, possibly more geared towards backend to backend communication. That's something that I'm interested if that's still kind of like the case. And one very interesting thing that drew my attention to GraphQL, and this is a question to Hassan, if something like that also happens there. So one of the things that kind of blew my mind, there's this feature in GraphQL, because it's geared towards, let's say, a mobile device that's now communicating with a backend, and bandwidth is very limited, and that's part of the stuff that GraphQL is supposed to solve. You have this idea that you can ask for something, but from the client you can say this specific property in the the document I'm asking or whatever, you can send it to me later at your own leisure. And this way the backend will send you the response immediately, but there's one field in there which I said that should come later because it might take more time to compute, right? Because it's going to come from some slow service in the backend. So that's going to come a little bit later. Another example of something in GraphQL is you can stream. So you can say, okay, I want all these books, but please stream them to me, or get me all of the properties right now, but this one I want to be streamed as it becomes available. So all these very non-traditional models of communicating with the backend, right? Usually we send a query, we send the query, we get the results. These models, which are very alternative, are very fascinating to me, and I wanted to know if you guys are looking into this as well. And so this is all GraphQL stuff. I'm interested. Go ahead, Hassan.
I can confidently say, that particular model that you just, I just call it eventual consistency. Eventually, you'll be consistent with a particular request that you sent in, and you're going to receive a notification somehow or a token that tells you come back later and get that. In the OData world, at least with OData Neo, the partial eventual consistency pattern is not something we're looking at today. That's not something we're supporting at all. It's either all or none. So you're putting a message on the queue and waiting for it to get processed. This is actually, so as a generic eventual consistency pattern, the OData Neo is going and saying, okay, instead of me having to be consumed through an API endpoint, you can just put a message on the queue, and whatever is consuming that message can translate that query into data and put it back as a response. Yes, but partially, not on that realm. I'm sorry. Go ahead.
Yeah. So the one question I have though, so we're talking about GraphQL and we're talking about OData Neo, and I just want to be clear for the developers who are watching this that are building applications today. There's OData today, and there's the new OData that's a vision right now. What is the reality or the timeline or the expectation around these
The new
features
capabilities.
materializing? Yeah.
So given the momentum and the kind of tempo of our development, I would confidently say like sometime before the next .NET Conf, we'll be able to show something very interesting for OData Neo. At least on the level of kind of technology being technology agnostic and being able to integrate with any technology. What makes this really interesting, again, the idea of rewritable software is that I can easily today make, partial deliverables through OData Neo. Like I don't have to give you technology agnostic from day one, but I can give you transcendence. I don't have to give you transcendence from day one, but I can give you, modularization where you can add your own capabilities into the system. So before .NET Conf starts, and whoever is organizing it, please, allow me to, to kind of show my, my work. I, there's a lot of people actually. Like the sessions that were coming in together, there's something more important than the technology there that really interesting about OData Neo, which is just the community passion for wanting to take OData to the next level. Like after 13 years worth of experience, 14 years worth of experience of people using OData and always wanting to do this thing, and then I was like, okay, let's do this thing. And they were like, really? Are you gonna really do that? I was like, yeah, let's do this thing. So yeah, that's the OData Neo will definitely have something that people can use in real time before .NET Conf. I think it's in September, Jeremy, right? Is that what it is? The next
Sounds
.NET Conf.
about right.
.NET Conf, yeah, September. Hopefully, nothing crazy happens. 2022, 2021. At this point in time, you never know what's gonna happen. But yeah, definitely we're shooting for that. And with the existing OData, however, just for people that are looking into that, you can still implement. Like batching is enabled today. Compute, Samshu just rolled out Compute. We did a demo for that. It's going to be published soon. You can also do fuzzy search, and you can do normal search through OData out of the box today. But also the last thing, which is really important, is that you can actually translate expressions down to the database. Now, with that being said, I have another question. So my understanding here, because there's this really popular article out there that says OData is not GraphQL. These are two different things. They are different and the same at the same time. Like they're like a Venn diagram. They have similarity in some parts and they don't have similarity in other parts.
I think.
Go ahead.
I would say they're really completely different, and that's what you. That's the first thing you should need, or that you need to accept, and then you can explore these differences, because it's just tempting to say they have something, like you can maybe do selections, but they are fundamentally different in their mindset and what they do and how they do that.
And that's true. Go ahead, Michael. Go ahead.
And let me just show maybe my screen. Yeah, let's go to this. So this is, we have always funny names for our tools, but this Banana Cake Pop, it's our GraphQL IDE.
Michael, I'm a little too old to see that small font. To help a brother out here and zoom in.
We can.
Same.
Yeah, they keep telling me get glasses, but it's just stubborn.
Oh, I got the glasses. It did
got
not.
The glasses, still can't.
Still can't see a thing. Don't get the glasses. They don't help.
Let's fix that up. We can do that. Not bad.
And then I've got a few questions queued up too, so I'm not going to do them now. But after this segment, I want to jump to some channel questions too.
All right.
Yeah, we should talk about security.
All right.
Yeah, I have a few questions as well.
No, I'm a bit.
I thought on a Mac it was supposed to be like super easy to do everything.
Yeah, it is super easy, but this is that escaped.
Yeah, there's only one button to click on the mouse, right?
No,
Yeah.
I was on my wrong display. That's actually my
excuses.
Right.
But okay.
So GraphQL isn't that good, I see. You can't change the fonts and all.
No.
I get it.
But I actually, the funny thing behind my Mac is I actually got my Mac to back almost 7 years ago to write .NET code. So when Microsoft started with .NET Core 1, I actually first started with a Linux box, but it was too much work. So I got the Unix for Windows users, I would say, and start doing .NET.
All right.
Linux
Okay,
works
but
great.
anyway.
Banana cake pop.
Yeah, Banana Cake Pop. This is a GraphQL IDE. And so why is how does GraphQL essentially work? We talked about OData and stuff like that. And in GraphQL, Shay talked about that. You have like streaming, you have like deference in queries, but what does it mean? So in GraphQL, I write a query essentially by saying, okay, I want to write a query. This means I want to just consume data, not change it. And then I write something that very similar looks to a JSON, an empty JSON graph, I would say. So I essentially can ask here maybe for assets. And this is one of our demos that we do with HotChocolate. Assets is essentially cryptocurrencies that we have here. And I can drill into my data structure. You can see I immediately get into a sense here. And it's very easy to compose these graphs. And then I can just execute that, and I get the data in the same shape back that I write my query. And that's why for front-end developers, it's so easy to do GraphQL. And if you go to a front-end developer that builds websites and stuff, it sells itself because they essentially specify what they want to have, and they get that in the same structure back. And that is one of the core concepts you have. And that's also what makes it very different from OData, because in OData, it's all about querying data in a traditional sense. This is not really querying data; it's more selecting data. Huh? That's one of the first things that you notice that are different. The second thing is that I can prioritize and deprioritize my data. For instance, I can say, okay, there is a section of data that is actually very slow. So
Michael, if you don't mind, Michael, just a sec. You could still do select in OData.
I know, but it's more about the mindsets behind that. And I did OData for years. Okay. It's just so simple for front-end developers because that is baked in. There is also the clients in GraphQL that use React are completely different written than you have an OData client. An OData client is more traditional. Here's my query, fetch, get that, and do something with it. Where if you go to...
Go ahead, sorry.
Yeah.
I was just going to say, I think there's a question that came up a while ago in chat, which is very relevant to this whole question. How do you implement iQueryable with GraphQL? And I remember having this conversation with you, Michael, right? And your answer was you don't. Right? You don't do an iQueryable because you don't write a generic expression tree which says this is what I want to select and this is what I want to filter by and all this in OData, in GraphQL rather. Whereas in OData, you very much would do this kind of thing, right? And I think that this is kind of what you're saying. It's like, yes, it looks superficially similar on the surface, but really the approaches are very different, and that's why we really don't have iQueryable with GraphQL.
Well then, Arthur,
and just let me show this bit. So we have the data structure, and we mark this piece is expensive data. So we want to get it, but we don't need it now. Give me when it's ready. And that's also why the clients in GraphQL, they are reactive clients. They work very different to what you do with OData. So if I fire that, you can see I get the data immediately, and then you saw a second later I got this piece of expensive data. And I could also defer more data to make this effect more better to see. Like maybe we get some history data here for our crypto coins. Let's get the nodes maybe, and then get the prices, historic prices. So and then you can see. Do you see? Did you see? I first got my data immediately. In 97 milliseconds, and then it took longer because actually these historic price data come from a very different server. It's a REST service where we get them.
Backup.
And yeah, it takes quite a bit. And when we look into our transport here, we can actually see that we got 1,000 patches. It's one HTTP stream where we initially get the first data, and then the data is patched. Like I get these patches on the same stream where it tells me, okay, the first JSON object is okay. Now patch this JSON object into this path here. And we want to patch into this path, this data structure. And that what is completing slowly my data. And there's another aspect here. Like if we talk about GraphQL, front-end developers completely differently build their applications. Like there is, and that's something, if you want to compare OData to GraphQL, it solves different things. Like if we look, for instance, at the documentations for Relay, it's one of the most popular clients. Like there's Apollo client, which has even more users, or there's Relay, which is essentially the client on which Facebook is built. And let's go in the step-by-step guide maybe. And there is a good way to think about how we actually build GraphQL clients. Just let me find the when to use Relay. It's a good thing that they always update that.
While you're looking for that, Michael, just a quick question. Does that mean I have to change my core logic? Does that mean I have to change my core logic layer implementation to have my API be graph queryable? Like if I have a service layer and that service layer has nothing to do with your exposure layer, right? And I want my service layer to expose, like my service layer is returning a list of students, right? And I want to add an exposure layer for GraphQL. Does that mean I have to change my core business logic to be enabled or GraphQL?
No, not really. But if you build GraphQL, if you build UIs or websites, it's important to understand how the community has evolved in how to fetch data. It's not about only data; it's about data stores and how you fetch data. So it's about I don't know if you know the concept around Redux, but this using GraphQL libraries around that makes it actually usable and easy usable. Like in your component, you would define fragments, which in GraphQL is for composability. It's essentially our primitive for composition. So you can essentially create fragment hierarchies as you create component hierarchies in UI components. And this is baked in. Like this is a typical Relay component that you have here, where I say I'm building my component, use this fragment, and this fragment immediately is compiled into my data structure that I can then use in my client. And I only say, okay, this component, my UI component, needs that data. And these fragments are then composed to the query. And I don't worry about writing OData queries or GraphQL queries. I just explain to my client, I need this data. This is my component data that I need for my component. And that will be then fulfilled. Here you see the fragment is defined, and then I just use in my component, in my HTML code, then the data from this component. It's very, very, very powerful how you use data, and that's a fundamental difference in how you use OData or what OData is for. In the projects I'm working on often OData is used for SLP. Just to query their data, and in the most projects we use when we want to make this data useful, we put GraphQL in front of that to make that useful for our front-end devs. So GraphQL is a middle layer where OData might be one of the data sources we use in that middle layer.
So it's in so your API. Just help me with this one, please, Michael. I'll take your screen for a second, if that's okay with you.
Yes.
This here, when we try to develop like core enterprise applications, right? You know, you have your integration layer and you have your service layer, which is where your business logic lives. If I have an API control, it's ASP.NET API controller sitting in here, what kind of work do I need to change? Where do I need to work to make this a graph queryable. So this is your integration here. Assume this is your client to the API, and this is your biz logic. And then this is your exposure, which is your controller API. Where do you change an ASP.NET Core API to make this graph queryable? Do you change
You,
here?
just, you just give us your API. So essentially, GraphQL is a thin layer of your business. That's the beauty of GraphQL. You take your business logic and you expose your business logic just to our GraphQL server, and we automatically you have a GraphQL server.
Okay,
with
so
all your business. So that's a beauty. If you, for instance, do clean architecture, they are always worrying about writing DTOs on top of their business layer. You don't need to do that. Give us your business layer, and we put this thin layer of GraphQL over it, and it's exposed. You have your API.
okay, so you basically add a layer in here, extra layer in here.
You don't have. So if you're using HotChocolate, you just say add HotChocolate, and you say add type, and we crawl your API graph from there, and it becomes automatically GraphQL. But this depends on the implementation, right?
Gotcha.
So this is everything we've talked about GraphQL really so far, and OData in fact has been very language agnostic, platform agnostic, right? We're talking about in general terms, but I think your question, Hassan, goes directly to what HotChocolate and the other things that Chili Cream create, which is they create the stuff that makes this just happen. So, and we've done sessions on that I'd encourage everybody to go look at and see how that works. So, for example, super easy if you're using Entity Framework, for example, that was one of the questions that came up, to then go and put HotChocolate and have it use that, and then expose that and use that in a ASP.NET Core app. It's just literally just a few gestures to make all that glue together and work.
So go ahead, Jeremy. Go ahead.
I was going to say, can we pivot for a second? Because there's a question that came up in chat, and I think is really important to application developers, and that's security. And when we're standing up a system that is open, it feels like it's open queryable, right? Because the client gets to control what they're requesting. How do I lock down security, especially role-based, right? So I want this person to only see a partial set of columns from this table, and that's what's allowable. So since Michael did the last segment, Hassan,
absolutely.
You want to go first for OData, and then Michael, if you can share for GraphQL.
So OData as it stands today gives you the kind of power capability to go control what kind of operations you want to allow, right? So OData gives you select, order by, filter, expand. It gives you compute, it gives you search, it gives you all of these different features that you can enable both on the application layer, the entire API controller layer, or a particular method or a particular model that is being served by a particular endpoint. So for instance, I'll just bring a quick example here. If you have an OData enabled API, let's see if I can share my screen here. Here we go. Can you guys see the world? Yes? Anybody?
Yep, we see.
Yep. So at an API level, you can actually go and say, I only want to allow select across my entire application. So people can only select fields, but they can't go beyond that, right? They can't do expand, they can't do, certain capabilities. You can also control pagination, like you can go and say max stop, and wherever your API is being consumed, so nobody can DDoS your API, you can go and say, well, if you're gonna pull a bunch of values from any queryable API endpoint that is exposing a bunch of things, you can go and limit that and say you can't consume more than 100 at a time, right? So that gives you a lot of capabilities in terms of enterprise development, that you can't just consume every single record from the API. But more importantly, you can also control at the controller level. You can go here and say, well, I want to enable query, but I want to go and say I want to allow certain capabilities like allowed arithmetic operations, and I want to only allow maybe module or all or in or add. I want to allow certain capabilities for logical operations. What else do I want to allow? I want to maybe allow the ors. I want to allow the ands and equals. So it goes really deep into every particular operation that you want to offer through your system at the API level, at the controller level, and across the entire solution. There's also the additional outside of the box capability where you can have your SQL Server adding particular security measures for certain individuals. This is the Lapadula security model, where you can write up and you can't write down and you can't read up. So basically, if you're a lower level of security, you can actually read at a higher level of security, someone that is writing data at that particular level of security. SQL gives you that outside the box. Entity framework transcends that, and then automatically OData adapts that. So you change once and impact everywhere, based on the security token that you're sending in from the client.
So
To
be a bit of a devil's advocate on this, and this all seems like, if you know to enable this stuff, then that's great. But if all you've seen is enable query, then are you not kind of exposed to denial of service by default?
That's a great question. Even if you don't know, it's part of you setting up OData in your API is to allow what options you want to enable. You can't actually enable OData by just putting in enable query on top of your controller. You have to set it up in your startup CS. So automatically, the engineering experience, there's a handing off security to you and letting you make the decision.
Cool.
Yeah. All right.
Do we want to see the GraphQL side?
Yeah, in GraphQL it's a bit simpler. Okay. Am I still sharing my screen? No.
You're in Inception right now, but
yes, let me share.
Somebody has to add it back to the stream again. That's all. When you share
I'm just waiting for it to appear.
Unincept.
Yeah, tell me when it's there.
Decept.
Still not seeing.
I think you need to share again, Michael.
Okay, let's do it.
Sharing is caring, Mike. Let's do it. Let's go to
there
town.
we go. Now Jeremy can.
Okay.
There you go.
Right.
So that's. It's not about simplicity there. It's more about explicit. In OData, we talked about all these operations that you have to deal with, and that's one of the main differences. Yeah, we are talking about APIs. So you're writing an API. This is a GraphQL API. Like I have a query here. That's my query type, and I'm very specific that I have an operation get book here, and that's my operation. There's no select on it. There's no automatic filter on it. It's what I put in the API that is there. That is why it's more an opt-in thing. So you're writing your API, and by default, we are not putting stuff on it. Or you don't have to think about computations and stuff. It's just this method. That's your resolver that produces data. The second thing here is, if we go then into our IDE to explore that, we can see that we just have the book here. We don't have any automatic operations just put in here. And we can just query what we have there. So it's more explicit. That's one of the things that are important with GraphQL. It's a thin layer over your API in .NET. You can opt to put in also automatic filters and stuff like that, and then we can make it more complicated. But by default, it's an opt-in. You write an API, you're very in control over what your resolvers do. So there are still security concerns that people in general have with such things, because how does this query perform? Maybe if I write a very deep query here, it doesn't perform to our expectations. And these, then you can put security concept in GraphQL in, like we could have a depth limit. So you're not able to go forever into the depth of the graph. Because I don't have cycles in my graph here, I cannot go deeper in this particular example. But I could, for instance, just say in my GraphQL query that I have maybe at max execution depth rule, where I say, okay, the execution depth of my GraphQL is 5, and then I can go only 5 levels deep.
Like as anti-DDoS, yeah.
Yeah. There are also other things, like I could talk about complexity. That is one thing. For instance, GitHub has a GraphQL API, and they are by default having a complexity of 1,000, which essentially describes the operation complexity that you have behind your graph. For instance, we could say that getting a book from a database has a higher complexity as just fetching a simple data field from already queried data. So with GraphQL, you can enable the complexity rules, and we will do that automatically for you. We will look where async resolvers is and analyze your queries and apply then certain complexity rules, and then you can measure the performance that the query has and say, okay, this is the impact on my system that I want to allow, that maybe is 1,000 or maybe 500 of your system, and then you can set, okay, no query is to be above that complexity. But that's a more complex thing where you have to think about if you really expose a public thing. Another thing in GraphQL is that if you don't have a public API, and public API means something like GitHub, where people can write their queries by themselves. But most companies, like the companies that I'm doing projects with, they actually don't have public APIs. They have a website that is querying against a GraphQL server. And that is not a public API in this instance, because we can then freeze the queries that are known. So essentially, when this is a production query, we would preserve that as a persisted query, like a stored procedure on our GraphQL server. And once the website is published on the GraphQL server, only these stored procedures will run. So nobody can write queries. And that is a very easy thing. All the clients support that. For instance, we looked at Relay. You have these persisted query capabilities here, and it essentially will export your persisted queries that you have with your client. You get such an ID for your thing, and that refers to a stored request on your server. So there's a lot of built-in security capabilities to not let people
so Michael,
hijack your server.
Yeah. So Michael, in a situation where you and I are consuming the exact same endpoint using GraphQL, and your security token and your profile on the system has access to more columns within a database than what I do, does GraphQL honor that?
What? If you do what? I didn't
So I
get
think
that.
he's saying role-based access, right?
Yeah,
So if I don't want
exactly.
Shai to see my payroll
yes.
information
Yes,
when I'm logged in.
Yeah, so that's basically just, and we modeled that to be like in an ASP.NET Core. You just do authorize. Then you put a role on that, and then you're done.
So this is an integration between the ASP.NET authorization model and the GraphQL, basically.
Yes.
Right.
So,
and
I'm sorry. Go ahead, Shai.
No. Go ahead.
So in an enterprise scenario, right? You have most of these security, schema is already done, on the database layer based on the role. Do you have to duplicate that effort on the model side?
No. We just so there's an integration. You can plug that in. Type modules that would infer that from the database. That's HotChocolate specific. It depends on your GraphQL server. So we would infer that from the database. You can do that, like dynamic models, but that's up to you. We chose to have also these support these authorization attributes and the policy base that you have in ASP.NET Core. But there are also other integrations that you could do.
So the biggest thing I've learned so far is that this should have probably been a 3-hour show.
Absolutely. No, it's such a big and interesting subject, really.
Do you have more questions you want to show, Jeremy?
Let me see. There's been a lot of chat. Let me back up.
So I have one here that I marked.
Go for it.
So it's basically asking about discovering metadata. And the assertion here is there's Microsoft endpoints using OData, but you have to read the docs to know how to query them. for example, Azure Pricing API. How does that work? How do you discover these things in both cases, or even do you?
I'll go first. In OData, there's actually a / metadata endpoint, that basically tells you, what's actually going on. And if you guys give me a second there, I can show you what that looks like. So, let's see here. So, I'm sorry. Go ahead.
Basically a self-documenting API concept.
Yep. So I'll spin up my OData enabled API endpoint here real quick. I'm going to share my screen. Just going to go to, there we go. So if I go straight into, just plays very well with Swagger. If you are, enable an OData endpoint, I don't know if you guys can share my screen. I already share. Okay, there you go. So you have that / metadata, area. And what this guy does is that it gives you a description of the capabilities, what you have on your API in terms of model. Okay, here's what you have available in here. If you're enabling, in this case here, I'm basically saying, okay, enable everything, go and search everything out there. But that's basically OData way of going and saying, here's the metadata underneath that API that tells you what that EDM model that we're looking at looks like, or how OData identifies it. And it's so generic, of course, because OData is a standard, right? So even if you're a Java guy trying to consume that endpoint, this makes so much sense because it's not really tied up to any particular technology. That's our side, at least. Good.
Okay, that me. So in GraphQL, this is built into the query engine. So essentially, I can query for, let's say, I can query for the current user. So maybe there is none, or Michael is signed in. But in the same query, I also could query for the schema. Like I can query for the types that I have.
So the schema is a subgraph of your schema.
Yeah, the type system is, think about it like reflection. You can not only query for the data, but also for the schema. And this is a very nice thing to do, because with that, dynamic clients can do a lot of stuff, like exploring their API, generating stuff, and things like that. And you can also, at each type, you can do these, we call it introspection in GraphQL. I can, for instance, ask, what's the type name of me? Okay, it's a user. So while you're querying the data, you can explore that. And this is why you also get these nice documentation here. That essentially we do that by querying the system. We can see, okay, there's a query. We can query by ID here. We can go in the asset. You can see what the asset thinks is. We also can maybe explore the schema a bit differently here, like digging in. And this is one of the things where the GraphQL tooling is just so great. When you start with GraphQL, exploring the schema is just another query, and all the tools can essentially do something like that. But GraphQL is also a schema definition language. That is, you can also describe the schema in this nice GraphQL syntax, where you essentially describe, okay, there's a type which is called mutation. We have here a field. A field is like a method in C#, where we have update user profile. We have the input here. You can see we have the update user profile input as a type that we want to pass in, and out we get the update user profile payload. You also have nice documentation. This would be the schema definition language. So you have both things where you can explore your schema in. So GraphQL is very, very rich in that.
And it's bi-directional too, right? You can use code to generate the schema, or you can use the schema definition language as the source of truth to start with.
And that's actually also one of the things when you start with GraphQL, and you don't want to do a lot. You have your old infrastructure there. For instance, with HotChocolate, you can then just type. Maybe I want to just that in, and that is VS Code. It's also very awesome because you have all this language support here. Okay, so this is now GraphQL document, and I can maybe write, okay, I have user type, and actually the user maybe has the name, which is a string. So very easy to write. The string is never null. And actually that comes from a JSON. So I'm fetching that from a REST endpoint. And that could be fed into HotChocolate. And I only have to provide to that a REST client. And then this would already be a running service, which serves just up your user. These things are called directives, and directives essentially allow to apply server logic. So by just applying that, I already applied functionality to that, a middleware that will fetch my REST service. So you can come from both ways. You can just write C# or you can logic on top of it.
Remember the REST days where you had an API, but you had no idea what you had there, right? That's the way the world used to be, and it's great. I mean, we're seeing both OData and GraphQL obviously doing this very well, and thank God the world the world has gone in this direction.
The huge thing is that ability to change what you want on the client without going and saying, okay, backend developer, can you change my, can you add another parameter to my REST endpoint?
Another
like
REST
OData
API,
and GraphQL.
exactly.
But
what about when we were doing SOAP? Even better, right?
Well, it was easy, right? Because it was the simple object access protocol.
WCF, it's
that
huge.
single mouse button again.
I'm proud to say I somehow managed to avoid doing those things like in my career. I kind of smelled bad. It smelled back even back then.
Child.
Yeah, exactly. Life is good.
Okay, well, I feel like we are a little bit over. I don't know if there's anything else. Arthur, Shai,
No, I think
Michael, Hassan. So just for the people viewing this, in our show links, we have a link to HotChocolate. We have a link to OData. There's a link to an article about Neo, so you can read up more about what's coming with that. We also have links to the new documentation that we added. So we should have you linked up, and I'm going to throw that link into the channel here. And that's all I had to say.
Yep. That's we always run over time. We should forget saying this thing is an hour long. It's never an hour long. But maybe if we said it was an hour and a half, then we'd just be doing 2 hours every time. So
right,
let's
keep it nominally 1 hour so we can run over.
Keep it. Anyway, so we will be. I don't. Does anybody remember what's up in 2 weeks? I always
I think we're going to be talking about pagination, which is something I discussed with Michael a few months ago, like very seriously, how to do efficient pagination in databases and so on. So everybody's invited. Very interesting subject.
Another topic full of another minefield, basically. There,
there's nothing but minefields in this place where we are. Yeah.
Yeah, okay. There's also very interesting concepts around that.
Yes, indeed.
Very much.
Okay, so I think so. Thank you everybody for participating, and thank you everybody for watching and sending your questions and everything. And we'll see you all again in a couple of weeks' time.
Thank you all. Pleasure to meet you.
Thanks, everyone.
Bye. Bye.
Goodbye.